Color cameras are functionally equivalent to the system of cones that we have in the retinas of our eye. Incoming light from the scene is focused by a lens onto an artificial retina. This artificial retina comprises an array of silicon photosensors. These are solid-state circuits that measure the amount of incoming light. They're actually sensitive to quite a broad spectrum of light. So to make them color sensitive, we print on top of these silicon sensors individual color filters. So we print patterns of red, green, and blue filters. This gives the individual silicon photosensor then the ability to measure the amount of incoming red, green, or blue light at that particular point on the artificial retina. Most color cameras use an array of color filters that looks something like this. This pattern of color filters is frequently referred to as a Bayer filter array and is named after Bryce Bayer, who invented this idea way back in 1976. The fundamental element in the Bayer filter is a 2x2 grid. It contains 2 green filters, 1 red filter, and 1 blue filter. For the purpose of example, imagine that each of the underlying photosensors is returning these particular values, and these are unsigned 8-bit integer numbers which vary between 0 and 255. And further, let's consider that we want to measure the amount of red, green, and blue at this particular point on the artificial retina. Well, the answer for red is really pretty clear. The amount of red at this point is 75. It's what's being returned by the photosensor after the light has passed through the overlying red filter. But let's say now that I want to know the amount of green light at this particular location. And that's problematic because this particular sensor has got a red filter on it. There's no way that I can measure the amount of green light there because there is a red filter, not a green filter. And what we do is simply average the green value of all of the neighbors, and we say this is a good approximation to the amount of green light at the pixel that's circled. Similarly, if we want to measure the amount of blue light at this particular pixel, we take the average of the neighboring blue pixels. So for every pixel in this array, we can measure directly one color, and we can estimate 2 other colors from its neighbors. If our sensor is an n by m pixel array, then we can estimate the red, green, and blue values at every pixel. That means then we have a total of 3 by n by m values returned from this artificial retina. But in reality, there are only n by m actual measurements being made. There are only that many individual photosensors. The rest of the values have been estimated. So an alternative approach is just to store the values directly measured by the photosensors, the n by m values, and then also take note of the properties of the color filters that are associated with the different pixels. And this is an alternative way of representing the image, and this is referred to as a raw image file format. It's different to a normal red, green, blue image. We need to do some post-processing, and we need to apply the characteristics of the filters in the camera to the data that's stored within the file.